Hello everyone. So today we are going to be looking at algebraic expansion or expanding the brackets. But instead of just giving you how to do it, we're going to look at an intuitive way to approach this by looking at these two elements, so my 4 and my x plus 2, as components in a shape's area. Now I'll show you what I mean. Now let's draw a rectangle here. And I'm going to say, oops, here we go. I'm going to say its dimensions are 4. And in this bracket here, I have two components. I have some unknown x and a dimension of 2. So I'm just going to split up this rectangle into two pieces. I don't need to know how much x is, but I can just write it here like this. X, and we have 2. Now, you can probably see that if I were to find the total length from here to here, so along this edge, that would be a total length of whatever x is added to 2. So down the bottom here, I'm just going to write that, well, this is like saying x plus 2 from here to here. Cool. All right. Now let's look at this shape I have here. So all my question is asking me is, well, what is the product of 4 and the product of x plus 2? Because when we just put it when we put this 4 next to the bracket like this, we imply a multiplication. So we are essentially asking, well, what's 4 times this bracket, x plus 2? And something that times as two components that can visually tell us about them is this idea of area. So what space does this whole rectangle take up? So we can say, well, to find our total area of our rectangle, we can say that, well, this is just the sum of our total area is the sum of these two smaller areas. Now, if I were to take 4 multiplied by x, I would have an area of 4x. And if I were to take the area of 4 multiplied by 2, I would get an area of 8. Now, summing these two areas together, I would just get 4x plus 8. Plus 8 as my answer. Cool. So why is that significant? Why have we done all of this? Well, we can say that by finding this total product, it is also the sum of two components which are multiplied together and added. Because have a look at this thing. Have a look at the answer we got here. What does that kind of look like? Feel free to pause the video. But to me, that looks like the process of first multiplying 4 with my first component and then adding that to when 4 is multiplied by the second component. And we get an answer. So that is how we expand brackets, and especially when algebra is contained. Now, if this is all you wanted to watch the video for, you can end it here. That's the end of our content specifically for this topic. But I want to just take another couple of minutes just to talk about the idea of what we've just done here and how we may have already encountered this before. Now, we intuitively do this when we deal with certain large multiplications. And maybe you might not, but this is something I did. And you may, hopefully, if you haven't done it that way, you at least understand the logic to it and why this relates to what we've done. Now, say I was to tell you, find me the product of 6 and 42. Now, obviously 42 isn't in our times tables. This is like a bigger number than we're used to, right? But how could we approach this to make it slightly easier? Because I don't know 6 times 42 off the top of my head, but I know that 42 is made up of two components, 40 plus 2. And I can say, well, okay, I don't know this, but I can say, well, 6 times 40, that's actually not too bad. When I multiply those two together, I get 240. And when I multiply 6 by 2, which is the next component of 42, I get 12. So my multiplication's way easier, right? And I end up getting my answer of 252. But we notice that when we have some number that we're multiplying by another one, we can break up this number in the same way that x plus 2 was broken up into an x and a 2. Now, some of you may have gone, well, I can't do 6 times 40 off the top of my head really quickly. That's okay, because this decomposition can be taken further as well. Like we can say, well, all right, I just want to deal with 10. That's a lot easier. So I can say, well, I can make up 42 with 10, 10, 10, 10, and 2. That's fine as well. And we notice the same thing happening because we can expand and multiply our 6 by every element here. And these will all add up together to give us the product we were looking for in the first place. So it's kind of just like the reverse way of what we were doing. So, okay, we have 4 lots of 60. If we expand this. And we also have 12 here. So 4 lots of 60, we have 60, 120, 180, 240, which is where we got last time. So we know we're on the right track, plus 12. And once again, we get 252. So this extra bit was included just to show you that although this looks weird and new to us because there's algebra, we actually have come across it before when we try to multiply larger numbers with certain numbers. We can break these up into smaller ones and just add them. In the same way that we said, well, our area approach that we've done up here is just like taking two components of my x plus 2 and looking at this in the terms of an area of a rectangle and splitting this up into the sum of two smaller areas. Now, in this case, we looked at 4x. Well, we looked at 4x plus 8, or 4 multiplied by the brackets of x plus 2. But you'll notice the same pattern because we're just multiplying our number outside the bracket by each number inside the bracket separately, and then just adding these two together. Now, these ideas will become clear as well when we look into binomial expansion in the next video. So that'll be a bit of a longer video and description, but I hope that this exercise gave you a more visual, intuitive understanding of what we do when we expand brackets in an algebraic sense. So I'll see you guys next time.